Okay, welcome to Unit 9, Lesson 2 this time. Our objective here is basically to understand the difference between rational numbers. Those are all the numbers you know, like things, nice numbers like 12. And then the integers, the opposites, the negatives. And then you got into things with fractions, and you've got decimals, including ones that end or repeat. And the other thing, of course, irrational numbers. Well, the first irrational number you ever learned was pi. And then now that you've gotten into square roots over the last couple of years, they are irrational. And square roots punched in the calculator look like this, a decimal that seems to go on forever without repeating. So that's what this lesson is going to be about. We're going to talk about rational versus irrational numbers. Let's go to section 1. All right, so here we go for lesson 2. Bottom line is we're going to talk about rational numbers and irrational. Well, rational, like I said, are all the ones you already pretty much know. A rational number is any number that can be written as a ratio, that's a key there, of two integers. So you may want to underline that piece, ratio of two integers, or circle it, okay? Such that the numbers here, like fractions and that, you can put them in as a fraction type thing, because that's what a ratio is, or you can also change them to decimals, and the decimals have to be terminating, meaning they end, or they repeat. If they seem to go on forever without repeating, that's going to be this other guy called irrational numbers. So we got rational numbers that terminate or repeat when in decimal form, or you can write them as a fraction. And then irrational numbers, any numbers that's not rational, so ones that cannot be written as a fraction. And if you put them in the calculator, they're non-terminating, means they don't end and they don't repeat, which means they seem to go on forever without repeating. And pi was that first one you ever learned. So let's look at exercise 1 here. It says, consider the numbers here, let's see, irrational that is 1 and one that is not rational. Take a look at the number 2/3, okay? So in part A, draw a picture of 2/3. So I can break this thing up into 3 parts. That's my thirds, that's the denominator, so I have 3 sections here, right? And how many of those are going to be colored in? Well, 2 of them. So I color in the first one, color in the second one. We've been doing that. You've been doing that since about kindergarten or 3rd grade, somewhere in there, and brushing them up, and you got 2/3 of the section colored in. Now, if I put that on the calculator here, and if you remember, you want to put 2/3 into the calculator, you do 2 divided by 3, you will get 0.666666, going on and on and on. Now, some of you panic, and because your calculator ends, and all of a sudden you got a 7. Does that mean it's done and it terminates? No, your calculator stopped there and it rounded off at that last part that it can go. Bottom line is it's really not a 7, it's a 6, and it keeps going, dot, 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 on forever and ever and ever as a repeater. And you can rewrite that also as a 0.6 with a bar over it. That's a repeating decimal, okay? Now, in part C, it says write all the decimal places out that your calculator gives you for 1/2. So if you punch in 0.5 and do the square root of it, so a second x squared, okay, that's your keys again. Once again, second x squared, so you got to hit the second key and then the x squared key, okay. That will give you the square root, and you can do 1 divided by 2, or you can do 0.5. And you should get on your calculator 0.707067812. It's as far as your calculator probably goes, unless you got a different one. Now, in part D, it says, why could you not draw a picture of this? Well, can you put that in fraction form? Can you actually take this now and put it in, hit math, enter, enter? If you do, to change it back to a fraction, it will tell you can't do it, okay? It won't actually change it. So you can't put it in a fraction form. So you can't represent it in a picture form like this up here. All right, here in exercise 2, they want you to show how all these square roots turn out to be irrational. So they want you to actually punch in the square, remember, second x squared on the 2 here. Punch it in, and you should get 1.4142135 and 2. Pause the video and do the other 2. Okay, so you should have gotten these other answers right here. If you pause the video, here they are. You're all set and ready to run. You shouldn't have a problem. Any calculator questions, please ask us in class tomorrow, okay? So we're going to move on to exercise 3. All right, exercise 3 here first. I want you to pause the video right away, and I want you to think about what two perfect squares that the square root of 28 falls into between, okay? And think about that as far as it goes, where it's going to be on the number line. So pause your video for a sec. Okay, I'm hoping you thought of, hey, it falls between the square root of 25, because that's a perfect square, and the square root of 36 is bigger than it. Those are the two it falls between. That square root of 28 is between the two, isn't it? Therefore, square root of 28 has to be between 5 and 6. Now, if you go to your calculator and actually punch it in on this one, let's see what we get. So we actually get 5.29150, etc. So does it fall between 5 and 6? Absolutely does. You might also notice that 28 here, okay, is closer to 25 than it is to 36. So I would think it would be somewhere on the bottom half of 5.5, which would be right in the middle type thing, okay? Doesn't work exactly like that, but it definitely is closer, so that should make sense in the number sense, okay? Moving on, square root of 28, write in simplest radical form. Well, we just did that in the last lesson. Break it up. Are there any perfect squares that go into it besides 1? Does 4 go into it? Yes, it does. Does 9? No. Does 16? No. And now I'm more than halfway, so it's not going to work. So bottom line is if I bust this thing up, you get the square root of 4. That's that perfect square. And times square root of 7. Okay? And if I simplify this, you actually get 2, because the square root of 4 is 2, radical 7. Now in part D, they actually want you to write out the decimal notation on this thing and see if the answers are the same between them, okay? So plug this guy into the calculator, do 2 times radical 7, and bingo, guess what you get? Same thing, 5.291502622. And that all goes back to the rules which we had on yesterday with busting up the thing that square root of 28 is the same thing as square root of 4 times square root of 7, okay? We're ready to move on, but these are all called irrational. Why? Because they keep going on forever without repeating. All right, in exercise 4, they want you to determine if something's rational or irrational. Now, once again, the way I look at rational is basically any number that seems to either terminate or end. That's what rational is. And irrational here are the ones that seem to go on forever without repeating. So they want you to punch these in the calculator. And all you have to do on this one is take 1 divided by 2 plus hit second, okay, x squared, and then punch your 2 in, and it will give you a decimal. When you add those two together, you get a half on the radical 2, and you will get 1.914213562. Now that's as far as the calculator goes. Does this thing look like it either terminates or does it end? Or does it repeat? No. So it seems to be going on forever and ever. So therefore, I would call this one irrational. Okay? That's what I would call on this first one. Pause the video for a moment now and try the next two and think about which way they are, whether they're rational or irrational for you as you do them. All right. So if you paused and you did the other ones here, you should notice, here we go again. This one turns out 4.95, blah, 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 going on and on forever without repeating. And this one goes 4.17, blah, 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 without repeating. And in each case, we were taking what is a rational number, like 1/2, 4/3, 7, those are all rational. And we are adding or subtracting to it a square root. That's not a perfect square, not a perfect square, not a perfect square. So those are irrational numbers. So out of all this, they want you to notice then that they all turn out to be irrational. Okay? So whenever I add a rational to an irrational, you should come up with, we'll go to the next page, and they want to know what happens when a rational is added to an irrational or subtracted. You will always get an irrational. So you can fill this in. So that's what they wanted you to notice out of that. Okay, so when we're adding or subtracting, if one of them is irrational and you add it to a rational, you're always going to get an irrational. So exercise 6 here. Why don't you pause the video and you can figure out which one of the following here, okay, turns out to be an irrational number. So pause the video. And they said, don't be fooled, don't get scared off here because of the square roots and stuff like that. Well, we know this one turns out to be 5, so that's rational. It ends like this. This is 4 minus square root of 9 is 3, so that's equal to 1. That's rational. This is just a fraction, which we already know if it's written as a fraction form, it's rational, so that's 3.5. But this guy right here is going to be the one that if you add the two together, 3 onto whatever square root of 6 is, you will get a number that continues without repeating. Does not end, does not repeat. So there's your answer, irrational. All right. That's what we got here for lesson 2. Write a nice WSQ, and we will catch you in class. Have a good one.